Welcome everybody to this talk about test automation and Jubula. And I'm very happy to see so many people because it's a side topic, testing. My name is Markus Tiede. For me, it's the first time at Eclipse France, but I've been several times at Eclipse Cons in the US as well as Europe. And I'm a former committer on the project. I'm still a committer, but I'm not actively committing. I've been for nearly 8 years working on the project. And since last year, switched a bit focus. I'm now doing release engineering and management in Switzerland, but nevertheless, quality assurance and testing is still very important in my daily life. And that's not at least one of the reasons why I'm talking today about quality assurance with Jubula. Whom of you is already using Jubula or has heard of it? Maybe some show of hands? Perfect. Nobody. I'm trying to do a couple of demos during the talk and do a hands-on comparison of the IDE and ITE, what we call ITE. This will be the main focus of the talk. At the beginning, I will do a brief introduction, what Jubula is in general, and at the end, pointing you into some directions, how to get started, and what's new in Jubula 5 coming with Oxygen. Does this sound okay for you? Yeah? Okay, perfect. So, Jubula is an Eclipse project since 2011. It's been formerly a proprietary project or tool for nearly 7 years or 8 years before we decided to open source it. And it's using a slightly different approach than most of the other testing tools, because in the beginning of Jubula and the beginning of GUIdancer, which was its former name, it was only targeting a non-technical user group. Yeah? That's why we've always said, okay, Jubula is a code-free testing tool. I now added a little star here because with the IDE coming into play and an API, like in the recent years, it's also you're also able to drive your tests via Eclipse or any other test execution framework. But we come to that later. Jubula allows you to automate your tests on a keyword-based level if you use the ITE, the integrated testing environment. And it's nevertheless, whether you use the IDE or ITE, you're seeing the AUT, that is the application under test, as a black box. So you're actually not running the same JVM, but you're focusing it from outside. It's a black box. You don't look at its inner structure. We support all of the major operating systems from Windows 7 to 10, Linux and macOS. And we have a toolkit approach, a cross-toolkit approach, meaning we support different Java toolkits and HTML toolkits. The most recent toolkit we or they have added is the JavaFX toolkit. All right. So all newbies, let's start with the first demonstration of the ITE, and let's take a look at test execution. Okay. And what I would like to show before showing the ITE is showing the AUT, the application under test, which we will use today throughout the whole presentation, more or less. It's the famous simple adder. I think we wrote this in 2005, one of the first projects of one of our students, and it's simply a simple graphical user interface being able to add two values. All right, so you can basically enter a value up here, and you basically get the result. So it's just to demonstrate some fancy stuff, isn't it? To demonstrate some basic interactions with the UI. And the ITE, this is the ITE. It's an RCP application meant for, as I said, non-technical users. to specify and execute your tests. Okay, and this has been for like 10 years the way to specify and execute tests with Jubula. You have it's an RCP application, you've got different views to manage your test suites, test cases, and to do things for testing. Test analysis, test tracking. And I would like to, as a beginning, resolution is a little bit low, start with the test execution and explain everything behind that ongoing. So I just select a test suite in the test suite browser and launch the test execution. What happens now is that we see a small test execution, 40 and 2 gets entered, and we click the execute button or the compute button, -1 and 1, and our famous 17 and 4, and we get jackpot instead of 21. Okay. So you saw like live tracking the ITE of a test execution graph. Data-driven, we simply fill a keyword with different data from outside, like the data we just saw, and we've got one failure. All right. So this is like executing tests with the ITE. And nevertheless, speaking of the ITE or IDE, it's always Jubula interacting with an AUT, right? So that's basically what you just saw. More specifically, you saw the ITE working. And what you didn't see is that there's the data for the ITE is stored in the database. Like for demoing purposes, it's an H2 database in memory. We can also use MySQL or Oracle and so on. But what you didn't see is that there's a third component in between, which we call the AUT agent. And this AUT agent might run as an embedded mode, like for this demo. It's a normally central process somewhere in the network where all of your AUTs connect to and get distributed to different ITEs. All right, so that's a background process, and it's currently running in embedded mode. And the ITE, and this is why we called it ITE for Jubula, also comes with a set of different tools, mostly meant for continuous integration purposes. There's a tool called AUT Run Test Executor. They're basically meant to drive like your test execution headlessly, either from an arbitrary continuous integration tool. And AUT Run is meant to drive the AUT's lifecycle from without the ITE. So starting AUTs independently from whether the ITE is available or not, this RCP-rich client. Okay, so this is AUT Run and Test Exec 4, and DB tool is basically a tool to extract data from into the database to get the interchange format, for example, to check it into some VCS system. All right. So test specification in the ITE is done on a keyword level, means you've got a pretty basic structure of test suites and test jobs in a view we call the test suite browser. And they simply reference, and you see this with this little arrow, they simply reference other test cases from the test case browser, right? And they're nested. It's basically like calling other methods, but without naming it. And you've got a couple of other test cases which use other test cases and so on. Might have an interface, for example, for value 1, value 2, and the result that you expect. And yeah, you basically build modules that you can reuse at certain locations. And within this specification, this graphical presentation test specification, you use like placeholder to access the UI components that you want to access during test execution. And these placeholders, we call them logical component names or component names. You simply map them to the application you want you want to like test or remote control. Okay, and this mapping is something I would like to show you next. We call it object mapping. Yeah.
Just a simple question about this vertical test.
Yeah.
Do they need having a screen, or can it be done in a virtual?
Oh, that's a very good question, thanks. The question was whether you need a real screen, yeah, or whether you can use it in a like virtual environment. Like Jubula is actually remote controlling and driving the mouse pointer and actually like setting keystrokes to the application. So you have to have a UI available. No lock screen, a UI available. You can use things like VMware, for example, or VirtualBox, where you actually have a virtual UI present, but you can't like run it completely headlessly. And we also had like major issues using RDP, for example, like RDP in an X virtual frame buffer. Those things might work, but we hadn't had that good results with that. Okay. So I wanted to show you what we call object mapping. We saw the execution, and I just mentioned that you are able to map a logical components to technical components, right? And you do that within the test specification perspective. And there's a small arrow up here. We call it object mapping, and you can start for any AUT that Jubula is connected to. You can set into an object mapping mode. And simply do that. Then we establish a connection to the application. And then while you're hovering through the AUT, it slightly depends on the toolkit, you get like green borders around the components that we support. And then you basically hit a magical key combination, which is Control-Shift-Q by default. And then you see on the other side that you either get a selection in a green or new components appearing in the editor on the other side. It's every time I hit this keystroke. All right. So that's the way how you collect these components from the AUT. And as children in this tree, in this mapping tree, you see these logical components that you use during the test specification. Okay. So this is how you link the real technical application to your test specification. Whenever a step gets executed, you use the most atomic thing in Jubula, and that's what's the link between the IDE and the ITE. You use caps, something we call caps. A cap is the triple of component, action, and parameter. It's the basic information we need to execute a step within an AUT context. So a component could, for example, be username text field. The action is enter some value, and the parameter is the value that you want to enter. So for example, enter username field and enter admin into that field. Okay, so this is a cap. And these caps are coming, or the C in cap stands for component, right? So there are completely different components in different toolkits. They're somewhat similar, but also different. So Jubula supports like SWT, RCP, JEF, Swing, used to support some mobile toolkits, it's not anymore, and HTML, and the most recent toolkit we've added is JavaFX. And with all these toolkits, you often notice that there's a common layer above that. And we have also added that to Jubula. We call it concrete or abstract toolkit. It's an abstraction layer where you have more abstract components to interact with. So basically on an abstract layer you have a textual component or you have a graphical component. A graphical component you can click, but you can assume that it has text. Right? And more concrete, you have got lists, tables, buttons, combo boxes, combo components, and so on. Yes?
Just why was mobile spot?
Lack of interest. Basically lack of interest. We try toolkits like once in a while, one toolkit per year sometimes. And we were, for example, this toolkit, we adopted other test frameworks to, for example, drive the AUT. In that specific case, it was KIF, Keep It Functional. iOS test a remote control driver, and we experienced that the person simply used that toolkit, that raw toolkit, instead of Jubula and tools on top of that. So we skipped it again. Yeah. And for example, for FX, you got concrete components like table views, tree views, and they somehow fit into these more generalized components in the abstract toolkits. And the idea is that for a test specification, you basically use a test specification that uses more generalized types, so that your specification may be used across toolkits, across AUTs, and so on and so forth. Okay? And during test execution, Jubula makes sure that you use the correct driver to remote control these components. So this is the ITE and the concepts of the ITE that we also ported to the IDE. That's why I'm talking today about that. I'm skipping a lot of aspects from the ITE that we could also talk about, but we are today concentrating on the aspects that are similar or especially different in both of these worlds. And what we did with the IDE support, or we haven't written an IDE on our own, but we simply exposed an API. And we exposed an API for establishing the communication to the AUT agent, a separate process to drive and manage the AUT's lifecycle, and to access these toolkit components, actually. Okay. So now you can use arbitrary IDEs behind that, arbitrary test execution engines behind that. Today we will see plain JUnit, a very simple setup, but you can use as a driving engine whatever you want. And you can even use, nearly completely use the IDE without accessing the ITE anymore. Okay, so you don't have to store your data in the central database anymore, don't have to use our exchange data exchange format and so on. When you see, and now this is a switch to the IDE or API usage. The first thing that you have to do, like manually, when you use the API is you have to create a connection to the remotely running, locally or remotely running AUT agent and connect to that. That might run anywhere in the network. Remember the chart. So we first of all connect to the AUT agent, and then we tell the AUT agent, okay, create a new process, another JVM, a new process, and here's how, right? Use something we call RCP, or an AUT configuration. There are different AUT configurations for different toolkits. In this case, an RCP AUT configuration, where you, for example, have a launcher, a working directory, some locales for the keyboard mappings, for example, that you pass to this configuration. And then you simply say, okay, agent, start this AUT. Agent, start this AUT. This is a blocking method call. And it either returns with a valid identifier if the process got created, or it fails with AUT start failed due to, and then you get some error messages, wrong working directory, file not found, and so on and so forth. Okay. And the next thing is you, with the valid identifier you get, you say, okay, connect me to this AUT. Okay, this is the second step. You first of all connect to the agent, and then you connect to the AUT itself. You can also disconnect from that AUT and connect to another AUT. It might be the same AUT or an AUT of a completely different shape. Okay, you simply connect to that. And at this point, toolkits come into play. You basically pass these, this connection establishment, the concrete toolkit that you're using at that point. And as soon as you've got your application up and running, you want to access UI components, right? You want to also interact with buttons, with text fields, and so on. And you do that by using the exact same mechanism as from the ITE. You basically go to your object map and say export, and you basically get a property file with serialized, we call it component identifier. It's a closed format. How we look up components. It's not a secret, but it's not part of the API how we do that. And then you can basically load this property file, get an object map from that, and get your component identifier. Like this is a raw, untyped component identifier. And after you created that, you haven't got your instance from the UI yet. Okay. The next thing is you pass that to a toolkit-specific factory to get a proxy instance for that component. And this proxy instance allows you, with other factory methods, to create cabs, executable cabs that are executable on a connected AUT connection. Okay. As I said, the tool is pretty old, nearly 15 years, and it's so we added over the time a lot of cabs to remote control the AUT, and there are over 200 cabs in different toolkits mapped to more generalized types and being very specific. You can imagine for a SWT tree table with multiple columns, you need a couple of cabs to remote control that properly. So simply take a look at that and you'll basically find what you're looking for. And when you got these proxy instances, I said you can execute that on a connected AUT connection, right? So we've got our proxy instance. We invoke a factory to get a cab instance for a click. For example, a single click with a primary interaction mode. And before we do that, we want to replace the value 1 text field, replace the value 2 text field, invoke the addition. This is a simple adder example, and check the result field. Okay, so this basically maps to what we've seen before in the IDE. And you do that on an AUT. You simply execute this, okay? And after that, you do whatever you want with the result, all right? So this is where our API ends. You basically execute this, and if it succeeds, simply the method returns. Or if it fails, you get an exception. Like in the ITE, we've got 4 different types of events that might occur. It's called either a configuration error, that should never occur, it's something internal that went wrong. A component not found. We weren't able to detect the component in the AUT, okay. A check failed, or an action error, okay. So we basically in the API get exceptions for that if it didn't work. And with the results, yeah, you basically are on your own. From that point, you can do whatever you want with the API. For example, like in this case, and we will also see it in the demo in just a second, you saw the 17 and 4 bug that we've implemented, and we're basically searching for that. We are starting at 17 and start with 1 in the addition, and we go up and search for the error, and we expect it to fail. This is why expected exception in this test execution, and we've got an assert at the end to make sure that we didn't run through the complete loop. Okay, I want to show you that. So we will close the ITE and open up Eclipse. And I just wanted to show you the dependencies that this project has. And there you basically see, or I hope you see, most parts that I've already explained. There's some, like in this case, JUnit is driving the test. It's a, you've got a couple of communication bundles that you need to establish the connection to the AT and AT agent. And you can choose what kind of API level you're using here. So basically toolkit API, the basic or concrete, or in this case, Swing API. The simple adder that we saw before was written in JavaFX, and now we are seeing it basically for Swing, but it also works for other toolkits. And some other dependencies for encoding and decoding the component identifier. So this is basically the class that we're looking at right now, and I simply run the test or run the I will walk you through the different steps that will happen. Because first of all, we should see, just make this a little bit bigger and remove this. First of all, we should see nothing, right? This is the place where we create the component identifiers and simply load the object mapping. And as it is a proxy instances, the AUT doesn't have to be there yet. So you simply load all of your object maps at the beginning, do that once, and it's loaded and ready to test. The next thing is we are connecting to the agent. And in this case, just to explain, we are using the running AT agent instance from within the ITE. So I haven't started any other process, just disconnected from the embedded AUT agent here, and it's still running in the background. And we are using that just to explain why there's no other process launched before. So that from the AUT. So we connect to that. And after that, we get the configuration. In this case, for example, for a swing. In this case, it's simply a java -jar call. You see it here, java -jar. And then the executable jar file name. And we say agent start. And now we should see something. We should see that the AUT is getting started. Okay, this. And we connect to that. And now we're ready for our test execution. Okay, and the test, as I already explained, will exactly do, let me just remove the breakpoint here. Do what I've said. It's searching for the error in a simple for loop, and yeah, expecting to fail. And that's why it won't fail, because it's, I hope it won't fail because it's expecting this exception. And for example, in a normal after teardown method, you basically clean up. You disconnect from the AUT first, and then disconnect from the agent to have the next test run ready. Okay, so this is the IDE-driven approach for Jubula. Like a slide to sum these both approaches up. The ITE, and this is the reason why we built it in the first place, has a very reduced complexity, and we always try to keep it as simple as possible, even these pretty complex mechanisms like finding and mapping components from the AUT. You know, it's simply pointing and you get your component. We try to keep it as simple as possible. And we aim for non-technical testers, and we try to gain high-level test cases that you can execute, that even a non-technical person can understand, or maybe you can go to your manager and he can also understand what's happening there in this test execution. You get pretty good test results reports. I haven't shown them yet. Beside these test results in the IDE, you also get an interchangeable format that's completely self-contained. It's an HTML file where you have screenshots and all of the failed paths, and you can also extend the other things that went right. And these are only a couple of things. We've got bird integration, ALM integration with Myelin. You can basically report your results back to Jira task or Bugzilla tasks and say, okay, this is still failing or something like that. The biggest cons is that there's no really good like distributed workflow other than working in a central database. But if you've got different locations where you work, you couldn't really check in your test specification and compare it. That was like a big disadvantage of the ITE. And for a programmer like me, you always said, okay, we are re-implementing the things that we have in the IDE and that you have in normal programming languages. Okay. The pros of the IDE or the Java approach is that you have the full capabilities, whatever you want to do with Java. It's developer friendly, it's plain text, it's Java, you can check it in. It's independent from any test framework. You can simply consume it and do any other things with it. You don't necessarily have to test. The remote control side, we specifically named it remote controlling, because that's what we do. We're not necessarily testing, but remote controlling an application. So you can embed it in different other contexts. And the remote controlling part is exactly the same. That's also used and maintained in the ITE. The other part is it's hard to use for a non-technician. You've got a pretty low execution of caps in that sense. And you get very technical test result reports. Basically, for example, a JUnit test result report without screenshots or without any like high-level traceability for a non-technical person. If you now want to get started, I would recommend to use what we call the standalone version. So we are an Eclipse project, and you get basically the ITE and all of the API from Eclipse and the repositories. Okay. Also, we are participating, I think, since 6 years in the release train. So there are many repositories filled with different versions that we support. But I would nevertheless recommend using the standalone versions that you get from the homepage from my previous employer, like testing.bredex.de. It's like a full package where you get all of the examples, documentation, all of the tools, the AT agent, and so on and so forth. And you can start with what we call, it's simply a cheat sheet, an Eclipse cheat sheet, which will guide you through the first test specification. You get all of the AUTs and so on. Okay. Then a small forecast, what's coming with Oxygen. What's been missing in the ITE are programming concepts. So we, or my former team, has now added concepts to have like loops and conditional statements in the ITE. They've did some minor improvements in the HTML reports. You now also get from the ITE JUnit test result reports. The component name handling is less strict, but that doesn't matter. You don't know Jubula either and its strictness in component name handling. And you can now have a special parameter in your data-driven tests to basically skip some of the executions of caps. And nearly all of the check caps, so caps that might fail with a check failed exception, have now a timeout parameter where you don't expect the value to be right in now, but in a certain time frame. Okay, yeah, I'm nearly done, thanks. So this should be it. Think about evaluating the session, recommending it if you liked it or not, and give some feedback. Here, and thanks a lot for your attention. I've got one additional slide because we've got like 2 minutes left that we might want to take a look at, but yeah, make questions first.
Just I'm not sure of having understood, so that's why I will ask this question. Is there any way to automate tests after compilation?
Yes, there is. Yes, there is. So the question was whether you have some automation to, for example, execute these tests after you changed something in your code, like locally or remotely. Yeah, there is, but nothing really built in. So there's no Maven hook or like a Jenkins plugin that you might use. There's basically a command line tool that you have to invoke with a decent amount of parameters, quite a lot of parameters to invoke it. And you always have to have a runnable AUT, a runnable application. It can't just be like one instance of a class, or it could be, but you have to have a complete application that's running. Okay. Yes.
For tasks that might take a while to execute, is there some kind of functionality to determine when a task is finished and when to evaluate it? So that when you click equal sign and it's a complex expression, it will take 2 minutes to calculate whatever you want to get the result field.
Yeah.
How can you determine when you want to actually evaluate this, that it doesn't evaluate it too early, or if something else ends up on the server and increases the load and it takes longer than you expected, you don't want to fail it for that reason?
Yeah, there are different scenarios. So there are built-in timeouts, and we expect any action and interaction to finish after, I think, 30 seconds. And from a UI point of view, the UI thread has to process the generated event within, I think, 10 seconds or 2 seconds. So otherwise it'll fail. And if you need to wait longer, and you might expect that, you can add specific, either you can increase the timeout because you're expecting that, or you can insert dedicated synchronization steps where you say, okay, I wait for like a state to appear, a window to pop up, or something like that. But you have to program that or to specify that into your test when you expect these and expect this otherwise unexpected behavior.
When you said just a wait event, it would still not try to evaluate before something has actually happened. So it will wait until the thread is processed or whatever it is.
Yeah, there are like 2 waits or different wait types. Pretty dumb wait, which simply waits and then checks, or waits that simply register a listener on that, and as soon as the state changes, the test continues. Okay, I just let this run for a second because I really love that and kind of geek. It's a demo for a very common problem in the, I think everybody of you knows, Towers of Hanoi. And I think the beauty of this is it's simply using, I think, one cap, and that is like clicking and drag and dropping, performing drag and drop actions in the AUT. And it's and the algorithm is also very, very elegant. I think everybody of you knows Towers of Hanoi, a perfect example for recursion. But yeah, I thought it might show it at the end if there's time. I think we got -2 minutes left, so that's okay. Yeah. Any other questions? Yeah.
Does it support Jubula NAT tables?
Unfortunately not. We had some, like once in a while there were like people that wanted to support that. There's an extension mechanism where you can add functionality to exactly, for example, support things we don't support yet, but no one has implemented that to a way where we say, okay, we take this and ship it. So unfortunately not. But it's not. It's pretty simple and it's doable. No, it's not pretty simple. It's doable. You have to write a plugin for the client and the agent, and yeah, provide some classes that do that. Okay, thanks a lot. Enjoy your time.